All right, we're going to be continuing on now with day 2 of section 2.3, real zeros of the polynomial functions. And today, what are we going to learn? We're going to be learning three things. We're going to learn how to use synthetic division to divide polynomials by binomials. We are going to learn how to use the remainder theorem to evaluate polynomials. And thirdly, we're going to use the factor theorem to find zeros of a polynomial. Today, your life will change. And you will be like, I'm so glad I went to math class and I watched these videos because math is off the frizzle. All right, so let's get going here. Synthetic division. All right, so there's a nice shortcut for long division of polynomials when dividing by divisors of the form x minus k. So yesterday we learned about long division, and we learned yesterday that if the remainder, when you do long division, okay, if you have a remainder of 0, then that means that whatever your divisor is, okay, so whatever your divisor is, then that must be a factor of that polynomial. Or in other words, you know that you found a root. You know that one of those, the factor that you found is going to be one of the x-intercepts. But sometimes doing the long division is very tedious, and it takes a long time, and it's very easy to make a mistake. So there is a shortcut to long division, and that's called synthetic division. And that's what we're going to learn how to do right now. All right. I'm going to highlight that guy right there, synthetic division. Okay, the pattern for synthetic division of a cubic polynomial is summarized as follows. All right, so check it out. So say if we're going to divide this polynomial by x minus k, the way that you set it up is you do these little brackets right here. If you are dividing by x minus k, you do the opposite of this. You're going to do k right here. And you do all the coefficients. So a, b, c, d, they're going to go right here. All the coefficients. Okay? And then this right here, you're going to do the opposite. If it was negative k, then you're going to do positive k here. So what you do is that you drop down the first term, a, and then you multiply. So a times k is ka. And then you're going to add these terms, and then put it right here. And then you're going to multiply. And you're going to put it right here. And you're going to add these terms, and then drop down the result here. And then you're going to multiply to get this guy. And so that's why I say the vertical pattern is you're going to add the terms. You're always going to add these terms together. And the diagonal pattern from here to here, here to here, and so forth, you're always going to multiply by k. Now, if that looks really confusing, it actually does look confusing when you do it with all these variables. Once I show you an example, you're going to be like, dude, piece of cake, calm down. So let me show you an example then. Okay, so we're going to do example number 5. And remember that this algorithm for synthetic division worked only for divisors in the form of x minus k. And remember that x plus k is the same as x minus a negative k. You say, what the heck is the purpose of that? Showing you that you use negative k when you do your value outside. So let me just show you how this works then. All right, so first we're going to draw a little bracket things. I'm not sure really what you would call these, but I'm just going to put them just like this. And you're going to do our coefficients right here. So 5, 8, -1, and 6. So 5, 8, -1, and 6. And since our factor is x plus 2, we're going to do -2 out here. So check this out. So we drop our first term, always, 5. And then we're going to multiply. 2 and -5 is -10. And then we're going to add these together. So we're going to get -2. Now we're going to multiply. Again, we multiply diagonally. And then we're always going to add vertically. 3. -6 right there is going to give us a -6. And we get 0. Notice that we get a remainder of 0. Do you remember what was the result when you have a remainder of 0 in long division? Come back up here. Remember, if you do long division, and if your remainder was 0, then that meant that the divisor was one of the factors, or it's going to be one of the roots. So in the same way, in synthetic division, if you have a remainder of 0, then that means that x plus 2 is one of the polynomials. In other words, check this out. If you take x plus 2 right here, okay, if you take x plus 2, okay, hold on, let me check that guy out. Right. So if you take x plus 2 and you multiply it by our results, okay, so this is the result down here. You say, well, what the heck is that? Those are just numbers. The way it works is this. See how our exponent started with the power 3? Okay, your answer is always going to be 1 less degree. So that means it's going to go x to the power of 2. So that's 5x squared minus 2x plus 3, and then plus 0 is not going to mean anything. Okay, so if you take this, 5x squared minus 2x plus 3, if you multiply this all together, you are going to get back our original problem. All right? That's one of the powers of that. And also one of the great powers of using synthetic division is we just did long division very, very quickly right now. We would have got the same answer if you would have divided this guy by x plus 2, but this is much shorter.